So we are going to start our first section of talks. Our first speaker for building smarter workflows is Yan Liu. Oh, yeah, come on up. Thank you so much.
Okay. Good morning, everyone. And thank you for the introduction. And thank you, David, has already covered a little about my package today. I'm Yan, a data analyst from the Providence Centers for Outcomes Research and Education. My topic today is how to leverage large language models in R. Since 2024, large language models have become more reliable and accurate. Recently, their potential use in healthcare and research have generated a lot of excitement, as these new models can perform the tasks that traditionally been labor-intensive. Our team from CORE has been exploring some opportunities to improve the efficiency of our daily work and to identify the potential use for program evaluation. Today's session, I'll cover some basics of the large language models and how to implement in R with ellmer package. And I will also show some practical applications and talk about some thoughts and key takeaways that you could implement in your work. Okay, let's jump in. At CORE, we work with a lot of qualitative data analysis. One of the main challenges is that the value of unstructured data, which will take a lot of time to handle and also affected by human bias. That large language models provide the solution, like the automating text analysis, content generation, translation in different language, and conversational understanding. That could increase the efficiency and the reduction of human bias. Today, I will show the use cases like the image to text generation, text classification, and summarization. And before that, I want to introduce a little about large language models. If you ask how many large language models in the world, and what's the best models, I would say it's hard to give exactly the answer. The large language models, the new models, developed and released every few days, and the tech companies like OpenAI, Anthropic, and Google, Meta, they have driving this innovation, creating various model with unique designs and uses. You can see this table that can have different developers and large language models, names, and the type of accessibility. And there are two main types here that is could access by API, and there is also open source model. And you may implement these models on the AI platforms or the ChatGPT website. And how to start in your environment? Actually, it's very simple. It's only two steps. The one step, you need to get an API key or download the model locally. If you are a student, you can just free to get an API key. And if you work for your organization, you need to connect your IT department and to figure how you can get an API key. And the second step is just you call the large language models to work on your environment, either R, Python, or other environment you want to work with. At CORE, we began with an open source model that is Llama 3.2 and Llama 3.3 for better privacy and security. However, this local model lacks robustness, and we found that it requires the advanced hardware to run it. Like the Llama 3.3, the model size is 43 gate bits. That means you need the powerful CPU, a large amount of RAM to run it. And this year we have the option to get the OpenAI API with the Azure endpoint. This is the four models that we can work in our work environment, like GPO4o, GPO4o mini, and two embedding models. So how can we run it in R? Like David introduced, the ellmer package that simplified the communication with large language models from various providers. Ellmer was released this January and have updated 3 times just in a short time. In this right side, you can see this is a different function in ellmer that you can implement the large language models. And the left workflow shows that use the data source and call the large language models, helping users use with ellmer and the prompt design to get the desired outcomes. In the next slide, I will show 2 examples based on accessibility models for our organization. That one is a chat R OpenAI function that we could connect with the R OpenAI models. And the second function is a chat llama that we could run the local models. Let's say the example. So you can see the left one that we connect the R OpenAI models and setting the parameters like the endpoint, the deployment, the model names, and the version, and the API key credentials. And I want to notify that you can see there is 2 prompts. The one is a system prompt. That is like a background or guidelines of the model. And the second is a user prompt. This is like the statement of functions you want the models to respond to. For this example, like I said the system prompt, you are a senior data analyst and R programmer, and ask the questions, tell me what is a t-test, and then it will give you a definition of the t-test. And then the right one, we can see this is a chat llama function that you could work with the local models. And make sure that you have downloaded llama. That is a software platform. It's free to download in your computer. And from its library, you have downloaded the local models in your computer too. And then you just call the models. Like this example shows, I call the llama 3.2, and with the prompt, you can just have some responses. And there is more ellmer functions that is super powerful. Like the ellmer can make the image input, and you can also do structured data, extract structured data, and call tooling, and compare results from different models. That will like you to explore after the meeting. I will show some practical applications, and first I want to highlight some workflow for developer use cases with ellmer in R. There's 4 steps. 1 step, you need to call large language models. Second, you need to design prompt and output structure. And the third, generate function. And the last one is the validation. I want to emphasize that the key considerations that you need to select the best model, the appropriate model to fit your special needs, and design a clear, specific prompt and output structure that could make your result more reliable and consistent. And also conducting various validation method will make your result both reliable and adapting to the changing requirement. So the first example is how we can image the image to test generation. The goal is that we want to have a description of the plot from ggplot or URL. So our example shows this upper left plot is from ggplot. And then we put our prompt design here. The prompt design, we focus on the output structure, like we set the title, XY, legend, and the summary. And then the result shows in the left, in the right lower. And we can see that the result is a text with different output type. I would say in general, the result is pretty accuracy, and that is too general. So if you want to tailor your outcomes and based on your special needs, you need to add your context into the prompt. That is, a prompt should be more specific, and you could get the more accuracy result. And the second application is the text classification, where our goal is automating, categorize the qualitative responses. And use ellmer, we can classify text based on different things. This example, I use the data is from Kaggle. That is a sentiment analysis for mental health. The size is around 53K mental text message that I'm so tired this morning, like these messages, and has been classified by these 7 categories. And I use this prompt. We can say this prompt here. It gives the specific instruction we want to predict the sentiment categories. And I also get the output structure that is different categories and the probability value. I also give an example for the final output. Then the result is here. Compared with the other method, like the traditional logistical regression and the deep learning method, the large language models, the GPT-4o, can give us that is around 77%. I think that is comparable to other method, and it's super easy. But I want to notice that for this example, when I use models, 20 minutes, the model deal with 1K text classification. I will say that is faster than human review, but not faster than my expectation. So prompt design and code optimization and time consideration need to consider in this example. And the last example, I want to talk about summarization. Our goal is we want to summarize different type of the articles and the reports, and we use our example is we do a literature review, and all the articles is from the local folder. They have different types like PDF, like message, like PPT, and then in the prompt design, we can say this is our output structures. I want to emphasize that like this, I specific some format here, like if I want to give the date, I want the format is month, date, year. And also like the summary of the articles, I said limited 50 words. If you put some constraints that it will give the response is accompanying with aligned with your expectation, and the result is saved in a CSV file, and this is the output table as we could say. And I want to emphasize some. When you use LLMs, that there is some limitation when you use it. The first is data security and privacy is a significant concern, because when you input sensitive data, especially in the online AI platforms, that is have the risk you expose your data. So some organizations, they just block or set firewalls to access the online platforms like ChatGPT website. So, and the cost of time is another concern, because running LLMs is not just expensive, but also time consuming. And the cost is not just a financial cost. It also affects the environment. So that's because the model will be high energy of use. And the third is the token limitation, because every large language models, they have a token limitation. Token is a basic unit that the large language models can process the text. And the models, if you input the text is too long, like hundreds of pages, that will make the model cannot process the text. And the statistic knowledge is another issue, because we know that the model is trained to the data that are available to a certain date. So you cannot get the latest information from the models. And the bias reproduction is the same too, because the data is trained by large data sets that could contain human bias. So that, and also if you call the large language models every time, it will yield a different result. So that make your result is not consistent. And the ethical consideration about responsibility is a bigger concern, that we know that the output, the result from the responses from the large language models cannot held responsible for themselves. So that is our responsible to take accountability for this, especially in healthcare and law area. And the input data copyright issue is also a concern because some organization and publisher, they forbid that they put their documents and data set into large language models. So you need to be careful of that. Our suggestion is that draft a clear and specific prompt design can improve your efficiency and consistency, and refine your code can make it cost effective and also efficiency. And always keep your large language models updated, and so you can get the latest information. And also conducting validation method, and so you can get your result more reliable. And the most important thing is that you need to define who oversees the result from the large language models and who should take the responsibilities. Okay, so the key takeaways today is that I want to say that large language models can help with the qualitative analysis, and it provides a simple way and an easy way to implement with large language models. And there are three practical applications with prompt design. And we talk about some limitation and suggestions that may be helpful for you use the large language models. I also want to thank you for everyone who made this work possible. That's our teams, Dan, Megan, also in this conference. And there is some resources for your exploration. This is the QR code for my GitHub, and all the code for our applications here. Okay, so because of the time, thank you everyone, and and ask me questions, and we can discuss it later. Thank you.
Thank you so much. So our next speaker is David Gerbing. I would also like to mention we are going to have a little bit of time after all three of our speakers for some questions. So after our third talk, if our three speakers can come up here, we'll have a little bit of time for Q&A at that point. Thank you.
Well, thank you. Thank you for the conference. Try to get closer to the microphone here. So my journey in data science started back when I was a freshman at Western Washington in 1970. And I still remember the courses, the faculty members, the computer science, the stat courses, and math and psychology. And the whole thing's like I'm still there almost. I realized my life is changing. So this is what I'm going to do for the rest of my life. And I'm fortunate to be able to do that. And I bring that up because I ended up doing SAS. I started before SAS 1.0 on punch cards in 1972. 73 is when 1.0 came out. So decades of analysis of SAS, decades of data analysis. And then around 2005 or 2006 at Portland State University, they needed me to teach marketing research for a variety of reasons. And what am I going to do? Everyone's doing Excel. Everybody's doing Excel. This is data analysis in the business world in 2005, Excel. Well, I can't do that. I don't know whether it's ethics or what, but I'm not going to sit there and tell people that this is data analysis using Excel. So I have to use something that's free. I'm not going to use stuff that they can't go and a lot of people teach Tableau, then they can't use it once the course is over with, once you're no longer a student. So anyhow, I wanted to use, and this R thing came out right about then, before then. I said, well, time for me to switch to R, and time for me to let students share this data analysis and show them real data analysis. My teacher ratings were not high that year. Okay. I tried to explain it. It didn't work. It's programming, and these people are not used to programming. So how can I make R accessible to students with no programming and let them do free data analysis? And I had to do it that way because for some reason, I just couldn't do it another way. So I ended up starting my R package around 2008 called lessR. And the idea is you just don't have to do programming to do data analysis. So it's trying to make things as simple as possible. Instead of a whole bunch of functions, it was what's the smallest number of functions I can use to be able to do data analysis. So this is a game I started playing for myself, and it took on a reality. If you're a geek like me, you'll understand why this is intriguing to me. It's a game I just took on its own life. How can I minimize everything? What's the smallest number of functions I can use to be able to do data analysis? And then it turns out there's all these packages out there. I'll just interface to these different packages with a common interface. And I didn't plan to do that. It just developed because that's what you need to do to be able to access these different packages, but then a common interface. Bottom up versus top down. So like in ggplot2, you start writing lines of code to get where you want to be. Well, where do you want to be? Well, there are spaces we want to be at, like an ellipse around a scatter plot kind of idea. So I just pre-programmed it. It's kind of like that old Greyhound bus commercial, let us do the driving for you, or whatever it was. We'll do the driving for you, whatever. So it's pre-programmed to get what you want instead of having to build it up step by step. And then the other point is, if I'm going to do graphics, why, if I want to see a bar chart, why don't I want to see the frequency table? Is there a reason why I don't want to see those? Yeah, there isn't. It used to be back in my punch card days, you would wait for hours for data analysis to get done. I remember many times having to wait overnight for my data analysis. This is no longer the case. It's all free, and it all sits there and comes out in our studio. So when you do graphics, do data visualizations, you get the statistics. Why call up extra functions to do that? And here's an example of this in terms of reading the data. All these different functions from different packages doing different data formats. It's just read, quote, and then the name of your file, the path name, the URL, or if you want to browse for it, just put in blank. That's it. Read, and then if you want to read it into a data frame name, obviously, attach it to it. So there's nothing more to tell students other than just read and write data formats the way you want. So if you want to access Feather and Parquet, for example, which is highly encouraged in the modern world, there it is, read and write. So when you read data in, you want to know something. Who wants to read their data in and shouldn't check as to the variables you read in, the missing values, and so forth? You should always look at what happened when you read your data in. So therefore, when you use one of my read function here, and this employee, if you just put the name, it's a data set that's downloaded with lessR, so there's not a full URL there or full path name. And so we end up with the information I need to know when I do my read statement. Okay, so now, what is the logical minimal amount of information that I need to do a data analysis? I'm not talking about I want some kind of programming language. I'm saying, what do I need if I want a bar chart of department? I need a function name called bar chart. And if that's too much typing, I can just type in BC lowercase. I need the variable name. And yes, I use a default here, which is D for data frame. So a lot of times we analyze data. Of course, we want multiple data frames with multiple names. Most of the time, we're just analyzing one data set. So if I read it into D, I don't have to say comma data equals D. I've talked to people who use my lessR in teaching, and they say they disagree. Fine, then just teach it comma data equals D. It's up to you. And so there is, now what do I want in a bar chart? Well, might as well put the percentages out there to begin with. And so forth. So bar chart department, data equals D if you want to, logical minimal information. And a pie chart. Now you already know how to do a pie chart because it's just pie chart. And then here's the analysis that comes out. Why would I not want to see my chi-square test for the null hypothesis equal proportions and so forth? So this just comes out at the R console. The other stuff comes out on the R studio or whatever you're doing, the plot window. Bar chart, department, group. Instead of saying group by, I don't want to type group by all the time. So I just type by equals gender, and out comes the two variable bar chart. Scatter plot. All my scatter plots are done with the plot function. You can say scatter plot, but plot's just much easier to type. So if you put in two categorical variables, you get what you want to see with categorical variables, which is a bubble chart. And you don't have to do programming to get the bubbles to show up. It's just done behind, the lessR detects. You've got two categorical variables, so it knows it needs to put it in this particular format. I also have variable labels built into the system. You just put an Excel file or a CSV file, variables in one column, variable labels in the other column, and read it in, and you have variable labels through everything. Histogram, continuous variables, histogram salary, again, minimum. And again, always an abbreviation, HS, if you don't want to type out histogram. And then if you want to get fancy with the formatting and things, there's many, many options like this. I don't have time to talk about them, but axis format equals comma, and then axis pre on the x-axis, put a $sign there. So you'll notice here, 60K, 80K. So this is done automatically for you instead of putting all those zeros in. And I got that from Tableau because that's the way Tableau does it. And I thought, well, if they can charge $1,000 a year to do that, I'll do it too. So anyhow, there's that formatting. The output that comes from the histogram. Why would you not want to see your summary statistics? Why would you ever do this analysis and not want to see your summary statistics? Or why do you want to start typing in functions to get additional summary statistics out? Outlier analysis, and then the frequency distribution. So I named this thing Integrated Violin Box Plot, Scatter Plot, VBS Plot. I have a publication in a journal on that name, but of course I did not invent this. It's my name, but I did not invent it, certainly. But I programmed it so you go plot salary, and you get the scatter plot, the box plot, and the violin plot automatically, and an outlier analysis. With this, actually should now it will label this outlier for you too. I'm always developing as we go. And then again, bi equals gender. We get the gender, and there's the label on there. And then facets. So this is originally called trellis plots by Cleveland in the 1980s. They called in ggplot2 called facets instead of trellis plots, which was the original name. And then I used the lattice package to do my trellis plot. So again, it's the same thing. I'm accessing other people's packages, giving you a common interface. So you just go salary. If you want facet, put facet 1. And then you get the output, gives you suggestions for other things to do, gives you the pivot table for what we just saw, and also parameter values that can be manually set. So when I wrote this is fine-tuned so that you don't have to go through and play with the bandwidth and play with the size of the points you're plotting. You don't have to play with the amount of jitter that's going to be in there. So I can give it 10,000 points, and it will make little tiny things and so forth, and give you different amounts of jitter. So these have all been tuned, but I can't tune it perfectly for everybody. So here's the parameter names. And you can just rerun it and change these parameter names as you wish. If you want a little bit more bandwidth, a little bit less bandwidth, change the amount of jitter and so forth. So plot weight by equals source, facet 1 equals cylinders, facet 2 equals trend type. So I have a book in CRC Press that's going into the second edition about data visualization. And basically it's lessR, ggplot2, and a whole bunch of other stuff. And in a ggplot2, something like this is about 10 lines of code or more. It shouldn't be more than a single line. Now, why do I say that? Because I have to teach to people who don't want to learn how to program. We want to learn how to do marketing research. And now, since I've done this, it just keeps on going, but just one line of code and we get all of this information out here. And here's the output that comes. The pivot table comes out automatically. So you can see the visualization according to 2 facets in a group by, and you can also see the actual numbers from which that was contributed all again automatically. And all the pivot tables come out for everything, and then just for each pairwise as well. Plot years and salary for the scatter plot. Here's the statistics that come out. And then, again, what do we want? Well, let's look at a confidence interval. Let's look at a best squares least line, best fit least squares line. Let's look at outlier detection. Let's look at the line without outliers. And then let's look at okay, so that one's not there, but this will come out for you automatically. All of this on here just by going enhance equals true to the scatter plot. Contour plots. I think contour plots are not used as often as they should be. We put ellipses around our scatter plot with ellipses, assumes multivariate normality. So instead of assuming multivariate normality, let's just see what the actual contours are. And so just go type equals contour. And this goes into a base R package that does this stuff. And again, you just do this. Facets by weight scatter plot by facet 1, facet 2. Make the points a little transparent. This here is because you need this lattice doesn't it overstrikes these, and so you have to slow it down and say do every other one, and so forth into 2 rows. So very straightforward to get out. We have 1, 2, 3, 4, 5 variable relationships here in one single plot. Look, fit lines don't have to be linear. Here's an exponential fit line. If you put plot errors equals true, you can see the errors. Here's the Tableau Superstore data, and we have order dates. We have sales, and here's 1 sale on January 3rd, 3 sales on January 4th, and so forth. And here's the time plot of that. So now I've accessed the packages Zoo and XTS, and we have the, say, plot, order date, and sales, and aggregate by months. Aggregate by months. And then here we aggregate by quarters. And here we plot 2 separate variables on the y-axis here, sales and profit with order date. So we handle time, we get the axes labeled correctly. We do forecasting, order date, sales. If I want to forecast, I don't want to go through a whole bunch of different functions and learn different packages. I just want to go, let's aggregate by quarters and go ahead by 4. Again, logically, how can I do it more simply? I can't, because I have to tell it that I want to aggregate by quarters and I want to go ahead 4 quarters. And there's my format there. T-test, salary as a function of gender. Why, when I do a t-test, do I not want to see the plot? Why would I not want to see the 2 groups? And then why would I not want to see the standardized mean difference, the effect size between them, and get a sense of what's actually going on there? And then, of course, I have a lot of output as well, too, for statistical output. So we end up with analysis of variance. We end up with ANOVA functions. We end up with a regression analysis, which will actually generate our markdown file automatically and do the artificial intelligence for you, just using its own logic. We have all sorts of stuff comes out in my linear regression, cross-validation, and on and on. We have logistic regression, and we have other stuff too. So there we go. That's just give you an overview. It's lessR, and I'll apparently continue to develop this stuff while I'm still alive, apparently.
Thank you so much. Next, we have Mauro Lepore.
Thank you very much. That was great. Today, I would like to talk to you about dverse, which is an R package that helps you to document a collection of packages, a universe. First, I'm going to be talking about why I thought that this package is useful. Second, about how you can go about using it. And finally, who is the main audience of this package. So starting with why, the reason behind this package is that I think that documenting a collection of our packages should be easy. It is super easy to do with just one package, with package down. So why not basically gather the documentation from multiple packages in just one place? To illustrate some of the pains that still remain when you want to actually do that, I'm going to be talking about the iconic tidyverse, maybe the ecosystem of packages that has icons the term universe in our community, perhaps. It is, at the more conceptual level, simply a collection of our packages designed for data science. And it has a couple of tools that implement some very convenient features. For example, I'm talking here about the tidyverse with lowercase t, which is the meta package of the universe tidyverse with capital T. The meta package has, for example, a couple of convenient functions like a couple of features that allow you to very conveniently do things at the level of the entire universe. Simply with install.packages tidyverse, you can install everything in the tidyverse without you even needing to know which are the individual packages that compose that ecosystem. Then you can use all those packages and attach them to your session simply with library tidyverse. So why not have a way to also centralize very easily the documentation or the access to the documentation to those individual packages? Surprisingly, the tidyverse does not do that. And one place that I think feels kind of natural to me as a user of the tidyverse could be that the reference section, for example, of the package-down website of the meta package tidyverse would have a way for you to find, I don't know, filter, which actually lives in the player, or maybe geoonPoint, which actually lives in ggplot2, right? Instead, what you find there is a collection of functions that belong specifically to tidyverse, the meta package. So you see a function, the first one there, for example, allows you to understand the conflicts between the tidyverse and other packages. And the last one there, tidyverse update, helps you to update the tidyverse. So you don't have a way to operate at the level of the collection. So to summarize this first pain point, I'm going to kind of wear the shoes of a user, and what I want is to be able to find all the health files of the entire tidyverse in a single place. And also, I want to be able to ignore the specific names of the package. Hide me, please, those details, at least until I learn more about the ecosystem. For the tidyverse, may not be a big deal because many of us are so familiar with it that the names of the packages that contain the different functions show up in our brains quickly. But if you're like me, developing packages for internal organizations, your users may not even know how you decided to name the individual components. They just know the name of the overall project, which typically is the same name of the meta package. And that should be probably everything that your users need to know. My second example to illustrate the pain points that motivated dverse is the other iconic universe, the tidy models. And here we do see what I would love to also see for the tidyverse, which is a table that allows you to find all of the functions in the tidy models. That's great. You just type a little keyword in that search box, say predict, and boom, you get hits for just the functions or data sets that match that keyword. That's great. So if that's great, then what is the pain point? Well, the pain point is not from the perspective of the user, but from the perspective of the developers. If you scroll and try to find the source code of that implements this table, you would find this file, which has more than 200 lines of code. I know this is small, you don't need to actually see what's there, but basically you can go to the source code and find great ideas about how to implement this table for yourself. But if you're like me, I want to quickly create something similar to that table, but for my collection of R packages, it's going to be hard work, right? You're going to be spending some time to try and adapt those 200 plus lines to your own use case. So here, I'm going to wear the shoes of a developer. So as a developer, I want to be able to do such a table, something that is a universe-wide reference, as easily as possible. And there is exactly what dverse does. The code that implements that table looks something like this. I'm going to walk you through this snippet of code. And the example that I'm going to use is the tidyverse. So we're going to be together walking through this code to do that table that I dreamed the tidyverse would have. But here, a note. I'm using the tidyverse and the tidy models ecosystems because they are very famous, and I hope that many of us relate to them. But to be able to find dverse useful, your packages don't need to be famous or don't need to be on CRAN. So the best case is when your packages have a website, and it's a package-down website, and all your packages live under the same organization. But even if that's not the case, you can still find a way to create something useful. With that note made, the first thing you need to do is to make sure that you attach to your session all of the packages that you want to document. So you do library tidyverse because the tidyverse does that. So here, just by doing that, I have everything that I need to use later dverse. Second, I need only 2 arguments for this function. The start of the show here is this function called dverse document universe. So the 2 arguments that I need are packages and a template. The template are the URLs that host the different functions and data sets in your universe. So let's start with packages. It's simply a vector of packages names. And here we have a convenient internal object in the tidyverse that is called tidyverse core, triple column, if you notice that. So that won't probably make very happy to the developers of the tidyverse, because as developers, we don't like people using our internal objects, but there it is. So that's a convenient way to stick everything in one slide. So I have my packages, and then the template. One easy way to get that template is to go to any function in your universe, for example, dplyr filter, go to the website, to your package down website, copy the URL, paste it here, and then wherever it says dplyr, you replace that with curly braces package, and then wherever you see the name of the function, say filter, you replace that with curly braces topic. So that's the so-called glue syntax, right? And dverse understands that, so it will translate those placeholders to the specific names of the packages and functions of your entire universe. So simply with that, then we call the function document universe. Here we are storing that in a variable name called docs. And I'm showing you only 5 rows chosen at random. So with this table, I want to show you the shape of the table and highlight 3 columns for now. Topic, the first one to the left, the 3rd column title, and the last one package. You might remember that the table that I showed you from the tidy models had those 3 columns. That's all we need. I also have found very useful the keyword column, because later I'm going to show an example how I can also split the documentation in groups. For example, instead of just showing you functions and everything, I can show you vignettes, I can show you functions, and I can show you data sets in separate tables. Before I show you the actual code to print the table, I want to make a note here that many packages import objects from other packages, and the tidyverse does that too. For example, the pipe, the old school pipe, remember the magreader pipe, that comes from magreader. So the tidyverse wants that object for the user of the tidyverse to have access to it without you having to do library magreader. So that's very convenient for your users, but it confuses dverse because the URLs that are created here won't take you anywhere. So this is a zoom in to the topic column. I'm just showing you the column's topic and alias for you to see what is actually the symbol behind those links. But those links are useless, so most likely you want to drop them. A very easy way to do that is with a little helper called isOnline that comes with dverse. So basically that function will return true if if a topic is online, and false if it's not. So here I'm showing how the first few topics in the table that we created are all offline. We don't want them. And then the last few topics are all online, so we do want them. So what we're going to do in the next slide is to pipe the docs that we created into filter, and just by calling dverse is online with the argument topic, all the topics that we don't want are going to be dropped. Then we pipe that into select to get topic, title, and package, the columns that I said were important for this example. And finally, we pipe that to dt data table with argument escape equals false, which what it does is, instead of showing you the raw URL, it's going to give you a link. So it's going to give you the name of the topic, the name of the function typically, or the data set that you care about, and you click on it, and boom, you go to the corresponding package down website of the corresponding package. So here I'm using this is the real output of this code. I'm using the keyword as underscore just to show that I'm matching topics across multiple packages. You see I'm matching as date from LubriDate, as factor from forecast, and so on. So this is the table that tidy model is provided, and now we need it ourselves for the tidyverse. Okay, so who might be a good audience for this package? I'm going to start very inclusive. Hopefully, the snippet of code that we developed together today is accessible enough for anyone to just give it a go and try it. You can copy this code and try it yourself. You don't need to be a developer to find it useful in the same way that I found it useful for myself to have a convenient way to explore the tidyverse in a single table without me being a developer of the tidyverse, right? So you don't need to be a developer, and you can pretty much start here. Copy this code, paste it, and then adapt it as you will. Another aspect of the accessibility, I believe, doesn't come really from dverse. It comes from the community overall. If you want to publish this somewhere, today is not really hard. We already saw some ways of doing it before. And now I suggest also using QuartoPub, which is also a free service that you can use with very little effort from your side. So in my case, actually, I haven't been using this service a lot. Just for this talk, I started playing a little bit and used from my terminal the command quarto publish and just the name of the file that has this code, and boom, now it's published online. You can find it yourself. So first audience, pretty much everyone hopefully here that is willing to spend a few minutes trying it out. And then second, the audience that actually motivated the development of this package is a developer of a collection of packages. So here is one real example, people from the dverse. It's a conceptual collection of packages, but also it is a meta package that implements some ideas in that collection. And one clever way they use dverse is by adding a little packages link on the package and website of the universe. So you can go there and see the packages, but you can also click on global search, and that will give you the table that we just created. Going fast a little bit here, this example is a fake admiralverse. If anyone here belongs or has heard of the Pharmaverse, it's inspired in that. And many packages are called admiral something, so this is the fake admiralverse. I just wanted to create this fake example to show you that you can split the documentation across groups. So here I created one table for vignettes, one for datasets, and one for functions. And I'm also overriding the default reference of the package on website of this fake admiralverse. So I think this is a good place, pretty intuitive, to find such a table. All right, this is the code that implements that overwriting of the default reference. And if you're interested in kind of a more gentle walk through these ideas, I've published a blog post on the Pharmaverse last year. And it also includes a video where I show how to create a universe, a meta package with very little code, simply a description file with the names of your packages under the depends, under the depends field. That's all you need. 5 minutes before you're done. All right, takeaways. Documenting a collection of our packages used to be very hard, or at least harder than I wished it was. You can now do it fairly easily, hopefully, with dverse document universe, and it's great for developers of universes. But if you're willing to try it, if you're not, you should go ahead and try it. And I hope you do. Thanks very much.
Thank you so much. So for our speakers, our first 3 speakers, if you wanted to come up, we now do have a few minutes for question and answer if anybody had questions.
Hi, thanks so much. I'm Nathaniel Phillips. I know of the Pharmaverse, and it's a really amazing collection of packages. So super cool to have you present this. I'm amazed by the technical work you've done to enable this. Super cool. I'd love to learn more about experiences you've had in developing this kind of documentation, and how do I want to put this? In many ways, I think we write the documentation, that's kind of the last step. But oftentimes when you're connecting these different packages together, when you write that documentation, you realize, oh my gosh, we have inconsistencies here. Wait, we had this there, but that should be there, and this looks different. I'm curious if you can tell me stories about times where that kind of wrapping up documentation kind of helps people see where things are working and where they're not, and then you see that iteration process.
Yeah, I have a horror story to tell. A funny one is, it's a little detached from your specific question, but I think it's a pretty cool one to share. And the reason why it's really good to build an abstraction above the details of your packages. So I used to work for a company called 2 Degrees Investing Initiative. The short for that was 2DII. So we developed a whole collection of packages called 2DII. Then the project was sold to a different company, RMI, which is now the one that hosts the farmers. And they are stuck with something called R2DII. So having a way to abstract that kind of details, it's really helpful. So what they could do now, and I'm no longer working in that team, but one solution to that problem is that, well, now they realize, as you said, now they realize that the name was a really bad name, because now it doesn't even, it reflects the name of the X organization. So one thing they could do is just to build a layer on top, create a new RMI meta package. And that's all their users need to know. When they install RMI, what's going to happen, the meta package is going to go and install every package called R2II, so from the organization. Sure, you'll see them in your environment. They're going to look different to what you expected, but at least you don't need to advertise the name of a company that doesn't belong to you. Yeah, so certainly, you totally grow your understanding of your system as you go.
Thank you. Any other questions? Oh, thanks, Connor.
Hi, I'm Oyana, and I have a question for the LLM presentation. So I know that you have like a certain view of the LLMs that you can use, and then one of their slides showed that ChatGPT was showing the highest accuracy. Would you say overall ChatGPT usually shows a high accuracy, or has it varied depending on what you input?
Yeah, thank you for the question. I think that is I tested different the models that we could assess. The ChatGPT-4 can show the highest accuracy among the models that we could assess. And also, I think that is based on different data source. You will have different results. Actually, I will mention that when I text this data source, the accuracy is like a higher, like 85, and the drop down when you add more text in your models. That is, I think, because the data source, we didn't have too much context, like how to define the 7 categories. And if you have more specific, I think, project information context in your model, and you can verify your result, that maybe the accuracy will change. Yeah.
Thank you.
Sure.
Do we have any questions in the chat? I don't have the Slack here with me at the moment, but we could also look there if there were any questions as well.
Yeah, we have a couple of questions here. So first off, for Mauro, if we have a package universe where the code for individual packages is not already online, is it possible and easy to directly build the documentation for the whole universe, or do we first need to publish the individual packages documentation online?
Yeah, great question. I think it's great because I can explain, what are the limits of dverse. So basically, the table that we created, that data frame that we created with all the documentation, the implementation of that is base R. You'll see that in the tidy models source code, and you'll see that in dverse 2. It's super straightforward, and I believe that that's useful in itself, because just with the table, even if it's not linked to any website, your users could discover the names of the packages that then they can go and browse. It's not the greatest user experience, but I think it goes a long way.
And then another question. And then one more question from there as well. Is this, let's see, is this for use also with packages you did not make yourself? My impression was that this is intended for packages you have written and documented yourself, but I wanted to check.
Yeah, great question again, because it's good to clarify. I don't develop I'm not a developer in the tidyverse, and I show you how I created that table for the tidyverse. So as long as you can do library something, that something is something you can use with dverse.
All right, and I think we have time for one more question. Right over here.
This is kind of an open question for Jan. As an LLM user in an organization and working with other people in the organization, because the whole ML frontier is changing so quickly. And sometimes I think it's confusing for us as an analyst to explain it to people and use things where it works and kind of balance the hype and the promises. And I just kind of wanted to ask for your own experience in the organization. Who do you work with? There were chats on Slack about privacy issues, and then we had a few questions there about validation. What do you feel as a data analyst, as a professional? How is it changing your lives? Who do you talk with? What kind of situations do you run with? And how do you navigate it as this whole landscape still changes?
Okay, thank you. I think that is a great question. I would say I use the large language models every day, and because I use GitHub Copilot, I use it in the ellmer every day to my work. That definitely improve my efficiency. But as we work in a health and care area, we needed to notice that the information is very sensitive. So when we use it and with our partners, like the project partners, they are external partners, and we needed to communicate with them if they permit that we could use large language models. That is very essential, because some partners they just don't want you put their data source in the models, and that you should follow their instructions. And also, I think it's changed so quickly. So I would say that just if you don't like it, if you like it, but you need at least to understand it, and you need to how it can change your life, change your work, and how you can leverage it. And that's, I think that's very important, because we know that there, like many people talked in the chat, there are so many R packages can work with LLM right now. It's not just ellmer, it's other packages. It's already many people work on it. So just to keep you updated, and that is very, very important too. And as I talk about the limitation, I think the limitation is a ethical consideration. That is, I think, is one of the important that should talk more about it. But because of time, I didn't talk it. But we needed to notice that if the model gives you the wrong answer and you use it, that is a disaster. So that is, you needed to be very careful. Thank you.
Okay, everyone, please give a round of applause to our first round of speakers. Thank you so much.